Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem that is to add one row to tree. So this is a medium level problem and we'll understand how we can solve this question. Before moving forward, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we are given the root of a binary tree and two integers val and depth. So those are the two val and depth given to us. Okay. And then we're going to add a row of nodes. Remember, this is the row of nodes need to be added, not a single node, but a row. Okay, with value equals val. Okay, at the given depth, whatever the depth given to us as the depth variable. So at that depth, we need to add a row of nodes. Fine. Note that the root node is at depth 1, and they mentioned it that root is at starting at depth 1. Fine. Now there's some rules they mentioned like how we should add it. It says like that given the integer depth, right? For each not null tree node current, that means say a current being the not null tree node, at the depth minus 1, like the given depth minus 1, we need to create two nodes with a value as val as current left subtree and the right subtree. So whatever it means to say is like say we have a single node and this is at depth, whatever the depth given to us, the minus 1. That means that at the previous depth a particular node is there. Okay, so what do we need to do? Like it may happen not a single node, there can be multiple nodes can be there. So first let's consider there's only one node at the given level. Okay, at the given depth minus 1. That means the depth we were searching for, in the previous depth we have this node. Okay, now what we need to do, we need to create two two nodes actually. One is on the left, one is on the right. Okay, we need to create two nodes and those two nodes will be the given val. The given val is given to us, so we should go ahead with those two nodes. Okay, so we should add those two nodes, like that's what it says, like create two nodes with the value val as current left subtree root and the right subtree root. Fine, so those two are done for us. Next, what do we need to do? So the current, so this was a current node. So this current node had some left subtree and right subtree by default. Like we should expect that it had something previously. So what we should do, that the current original left subtree should be the left subtree of the new left subtree root. So what is the new left subtree node? This one we created. So what we will do, whatever the current like this particular node's previously left subtree was, we'll add it to the left subtree of that our new node. Okay, we'll add it to the left subtree. And similarly, the current original right subtree, whatever the original right subtree we had for the current, we will should be the right subtree of the new right subtree root. So it should be the right subtree of the new right subtree root. Okay, so this is the new right subtree we created, like the root is there, and in that we will we'll add it to the right subtree of a new one. Fine, so it's normal. So whatever being on the left, okay, let's just understand it simply, whatever be on the left subtree of our original node, okay, we simply added the whole subtree as our new node's left subtree. Okay, and then whatever be originally was there on our right subtree of our like the given node, depth minus 1 node, we simply added that to the right subtree. Okay, remember this left subtree is there's nothing over here, and also this right subtree there's nothing over here. So whatever be on the right subtree of the original node added to the right subtree of the new node. Okay, so that's what we need to do. And further, so this is the basic observation. And what if there are multiple nodes at a single level? Say multiple nodes at a single level. Okay, in that case also we'll need to add two nodes, like the same value. Same value need to be added. Okay, say this two comes up to this, and then this, and then finally it comes up to some other node over here. Fine. So if those are the situation, then you need to add two nodes with value v as well. So that's the more or less the idea we should follow. Now there's another rule given to us, the fourth rule. The fourth rule says if the depth is 1, remember, so depth like it by default says that the root node given to us is at depth 1. And what if we are given a depth is 1? So in that case there's nothing called depth minus 1, right? So there's nothing, depth minus 1 remains there. So if the depth is 1, that means there's no depth minus 1 at all. Then create the tree node with the value. What if in that case, what we need to do, we need to create a tree node with the given value val, I'm just writing v for that, as a new root of the whole subtree. So of the whole tree, and the original tree is the new root's left subtree. So whatever the original tree was, in that case we should add that to our new roots left. Okay, in case of depth equal to 1. So this should be done. This should be done for us, right? So that's the whole case. Now, this is like pretty simple. If I just show you the example of the, what do you say, the example given to us, you can find something like this, okay? Say, we are given initially, see, the root being 4, then 2, 6 are the left and right, and then on left of 2 there's 3, there's a 1, and there's 5. Fine. Now what do we need to do? We have a value 1, so value 1 should be added. That is the new, whatever the new node we should create, the node val is 1. Okay. Now further we got a depth equal to 2. That means, see, depth equal to 2. So this is a depth equal to 1. This thing says initially as depth equal to 2. So what we should do? Depth minus 1. We found that is 4 is the depth minus 1. So in that we created two nodes, left and right. Whatever was there in our left subtree, that is 2, 3, and 1, we shifted the whole thing to the left subtree like this way. Whatever be on the right subtree of the original node, we shifted the exact right subtree in this format. And see what we did, we got two nodes with val 1, val given to us as 1, fine, and then two nodes, and then we on the left node, okay, on the left node we shifted our left subtree, and on the right of the right node we shifted the right subtree, original right subtree. So that's what we did. That's the exact thing they are asking us to do. Fine. And a similar thing is also denoted over here. The depth is 3. See, that's 1, then 2, and then they added a depth 3. Fine. So depth minus 1, whatever is left, whatever was there on the right, it remains on the right. So that's the whole idea. Okay, that's the whole idea how we should go ahead with it. Now let's quickly try to write this code, because we'll be going ahead with the kind of the rules they have given us, and the rules will follow as it is. So in that case, it will be much easier for us to go ahead with the rules. Okay, this 4 rules, whatever the rule is there, let's quickly write them down. That would be much easier for us to find a solution to this. Fine, let's quickly go ahead with that. And that's how you see it's like a 0 millisecond solution. Let's quickly understand what exactly we did. We didn't do anything out of the box. We just followed whatever the rules given to us. Okay, let's see. We just took an additional function, and this function we named it as solve and passed it the root, val, and depth, the 3 things given to us, and also a level that is initially 1. So that is the level being the depth or the level of the current node. Okay, so whatever the current level we are at now. What we did, the first thing is the root is null. In case a root is given null, there's no point going ahead with it. So we just like return null. So there's no point. Now, this may not be a very useful case, but that's we should be careful of. Now, what next we did? If the depth is 1, okay. So if the depth is 1, there's something given for us, right? We simply did it. What it says, like if the depth is 1, that is there's nothing called depth minus 1. In that case, we'll create a new node with the val, that is tree node, as a new root of the whole original tree, and the original tree is now the root's left subtree. Fine. So we just created a new node with the val. Fine. And now the new node's left being our root given to us. Fine. And then we return the new node. So that's done. We just returned it out of the box. Next, we went ahead with the next case, that is the if the level is depth minus 1. That is a cases given to us over here. Fine. What I did, we created a new node that is the value. So once we got depth minus 1, that means we are at the level where we should add our new nodes, right? So we got our new node being created first. Then we did what? The new nodes left, let's point it to the root left. So what it means, just quickly, just if I just mark it to you, then say it was a previously like a depth minus 1. Okay, so I'm just writing d minus 1 level node. Fine. So it was pointing to some of the left subtree. Okay, I'm marking this is subtree. Okay, now see what we did. We created a new node over here. Fine. This is a new node with value val. Then we pointed val dot left is let me just draw it in a better place. So what I did over here, say over here, fine. What I did, so val dot left is root dot left. The root dot left is pointing to this. So we just mentioned hand dot left is this. And then I marked it as we then erased off this connector and then said simply root dot left is val. Root dot left is this new node. Okay, so we just marked it in that way. So that's actually, if we just look, So it was like the initial root over here. It was like the subtree over here, and this is a val new node we just created, right? So we just marked it in that way. So that's what we did in the first realize. Next, you should be confused of what we did over here. The next thing is like pretty much similar to what we usually do. It's like simply went ahead with this reuse this variable, and whenever we do a new pre-node or new something, it just reinitializes. Okay, so there's no point with something previously being the same node. Okay, so this is not a new same location being assigned. So this is not the same location, fine. This is a new locations being assigned. So that's how the new keyword works. So in that case, what we did like in this case, we just did the same thing with the right. So new node right is root right. We just pointed to the new node's right to the rest of the subtree, and then we just pointed new nodes right to the like the root right to the new node. So just connected the pointers. Okay, so that's what we did. And the else, like if the level is not at depth -1, that means we should traverse much more depth, right? We should traverse a bit more depth. So in that case, what we did, we just called solve 2 times with root left and root right. And what we did, we just added level +1. Just increased our level. So that's the whole idea. That's the whole idea being followed in this. And like once it's done, we simply return the root. We're done with the stuff we're trying to do, and we're simply returning. So it's done. Okay, so that's how it's done. That's how, as you saw, it's like a 0 millisecond solution as well. So simply follow whatever the steps given to us as a rule. We simply followed that, and it's faster than 100%. So I hope this can be understood easily. If you have any doubts left in this question, make sure to comment them down in the comments as well. I'll be happy to help you out in the comments. Also, like this video and subscribe to this channel for regular LeetCode videos like this. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.